Namaste, Shubhodaya, and a warm welcome to the viewers for the CSIR-sponsored CSIR-4PI organized Vismaya Vigyana YouTube lecture series Season 2. During the previous session, we introduced the concept of big data seismology and its relevance in the field today. Further, we discussed the volume, velocity, and variety of seismological data and the challenges involved in managing and processing this data. We also explained the role of big data technologies in seismology, including cloud-based storage, distributed computing, and high-performance computing. The present-day applications and the potential futures of big data seismology in earthquake detection, seismic imaging, seismic hazard analysis, and early warning system will be addressed in today's session. The link of the two previous sessions has been given in the description box in case if you want to visit it once again. If you have any queries regarding the subject spoken, please feel free to email at jigyasa4pi@gmail.com. You can also find the mail ID in the description box. Without any delay, let's welcome our speaker, Dr. Anil Earnest, to the forum. Hello, sir. Welcome.
Yeah, good morning and thank you for the nice introduction. I will try to share my screen now.
Please do, sir.
Good morning, one and all. Uh, our previous talks were on the introduction of the concept of big data seismology and its relevance in the field of seismology. We discussed about the volume, velocity, and variety of seismological data and the challenges involved in managing and processing this data. We try to explain the role of big data technologies in seismology, including cloud-based storage, distributed computing, and high-performance computing. We try to highlight the applications of big data seismology, including earthquake detection, imaging, and seismic hazard analysis, including early warning systems and all. Today's talk, we are trying to address the applications of big data seismology in earthquake detection, in earthquake location, earthquake magnitude estimation, seismic imaging, seismic tomography, seismic hazard analysis, monitoring of induced seismicity, and advances in early warning systems. We will be even looking at the low-cost community-developed sensor networks and its links with the big data seismology as a domain. First, earthquake detection, location, and magnitude estimation are critical tasks in seismology that rely heavily on big data technologies. Below are some of the ways in which big data technologies can aid in these tasks. 1. Earthquake detection. Seismologists use seismic networks to detect earthquakes by analyzing the seismic waves generated by events. Machine learning algorithms can help to automate the detection process by identifying earthquake signals from seismic noise. This can largely improve the speed and accuracy of earthquake detection, particularly for smaller magnitude earthquakes that may be difficult to detect using traditional methods discussed earlier. Earthquake location. Once an earthquake is detected, the location of the event must also be determined. This is typically done by analyzing the arrival times of seismic waves at different seismometers in the network. Machine learning algorithms can be used to improve the accuracy of earthquake location by modeling the propagation of seismic waves. Below figure shows the top panel shows the earthquake location identification using classical techniques, and bottom panel shows how that can be improved by adopting machine learning techniques. The bottom panel shows that the usage of big data techniques can largely improve identification of even very small magnitude earthquakes. Magnitude estimation. The magnitude of an earthquake is a measure of the energy released by the event. It's typically estimated using the amplitude of seismic waves recorded by seismometers. Machine learning algorithms can help to improve the accuracy of magnitude estimation by accounting for various factors like distance between the earthquake, and seismometer and type of seismic waves recorded by the network. Overall, the big data technologies such as machine learning can improve the speed and accuracy of earthquake detection, earthquake location, and magnitude estimation, which is critical in earthquake monitoring and early warning systems. Seismic imaging and tomography are important techniques in seismology that involve the use of big data technologies. Below are some of the ways in which big data can aid in seismic imaging and tomography. Seismic imaging. Seismic imaging is used to create detailed images of the subsurface of the structure of the Earth. This is typically done by analyzing the reflection or refraction of seismic waves at different layers of the Earth's crust. Big data technologies can be used to process and analyze large volumes of seismic data from multiple sources. For example, seismic networks, boreholes, and ocean bottom seismometers. This can help to create more accurate and detailed images of subsurface structures, which can aid in resource exploration, geological mapping, and seismic hazard assessment. Seismic tomography. Seismic tomography is a technique used to create 3D images of subsurface or structure of the Earth by analyzing seismic wave velocities. This technique relies on the use of mathematical algorithms to invert seismic data into subsurface velocity models. Big data technologies can be used to process and analyze large volumes of seismic data from multiple sources, which can improve the accuracy and resolution of seismic tomographic models. Machine learning algorithms can also be used to optimize the inversion process itself and hence improve the quality of the resulting models. Overall, the use of big data technologies in seismic imaging and tomography can lead to more accurate and detailed images of Earth's subsurface, which can aid in resource exploration, geological mapping, and seismic hazard assessment. Similarly, for seismic hazard analysis, it's an important task in seismology that involves assessing the potential risks posed by earthquakes to human populations and infrastructure. Below are some of the ways in which big data technologies can aid in seismic hazard analysis. 1. Data collection. Big data technologies can be used to collect and analyze large volumes of seismic data from multiple sources, including seismic networks, satellite data, and social media. This can help to provide a more comprehensive picture of seismic activity in a particular region, which is critical for assessing seismic hazard. 2. Ground motion prediction. Seismic hazard analysis involves predicting the ground motion that will be generated by an earthquake. This can be done using ground motion prediction equations, which are mathematical models that relate earthquake magnitude, distance, and other parameters to ground motion. Big data technologies can be used to improve this ground motion prediction equations by analyzing large volumes of ground motion data from multiple earthquakes as well as from multiple regions. This can help to create more accurate and robust ground motion prediction equations, which are critical for assessing seismic hazard. Next is a risk assessment. Seismic hazard analysis also involves assessing the potential risks posed by earthquakes to human populations and infrastructure. This requires the integration of multiple data sets, including seismic hazard maps, population density maps, and building inventories. Big data technologies can hence be used to process and analyze these data sets to create more accurate and more detailed risk assessments. Machine learning algorithms can also be used to identify high-risk areas and high-risk populations, which can aid in emergency preparedness and response planning. Overall, the use of big data technologies in seismic hazard analysis can lead to more accurate and comprehensive assessment of earthquake risk, which is critical for reducing the impact of earthquakes on human populations as well as infrastructure. Next is how big data technologies help in aid in monitoring induced seismicity. Induced seismicity refers to earthquakes that are caused by or triggered by human activities such as oil and gas exploration, geothermal energy production, and underground mining. Monitoring of induced seismicity is important to understand the potential risks and impacts of these activities and to take appropriate measures to reduce the risk of damage or injury. Below are some of the ways in which big data technologies can aid in monitoring induced seismicity. 1. By data collection. Big data technologies can be used to collect and analyze large volumes of seismic data from multiple sources, including networks, satellite data, and social media. This can help to provide more comprehensive picture of seismic activity in a particular region, which is critical for monitoring induced seismicity. 2. By proper event detection. Induced seismicity often involves small earthquakes that can be very difficult to detect using traditional seismic monitoring methods. Big data technologies, such as machine learning algorithms, can be used to analyze large volumes of seismic data, hence, or so as to detect and locate very small earthquakes that may be missed by traditional monitoring methods. Source characterization. Understanding the source of induced seismicity is important to assess the potential risks and impacts of human activities. Big data technologies can be used to process and analyze seismic data so as to characterize the source of induced seismicity, including the location, magnitude, and frequency of earthquakes. This can help in identifying potential risks and take appropriate measures to reduce the risk of damage or injury. Below figure shows the improvement of identification of induced seismicity, especially very small magnitude earthquakes, by using machine learning algorithms. Next is a risk assessment. Monitoring of induced seismicity also involves assessing the potential risks posed by earthquakes to human populations and infrastructure. Big data technologies can be used to process and as well as analyze multiple data sets, including seismic hazard maps, population density maps, and building inventories, so as to create more accurate and detailed risk assessments. This can aid in emergency preparedness and response planning. Overall, the use of big data technologies in monitoring induced seismicity can lead to more accurate and comprehensive assessments of earthquake risk, which is critical for reducing the impact of earthquakes on human population as well as infrastructure. Next is advances in earthquake early warning systems and how big data seismology is aiding this advancement. Earthquake early warning systems are designed to provide advanced warning of an impending earthquake so as to or allow people to take protective measures before the ground shaking starts. The use of big data technologies has enabled significant advances in the development and implementation of earthquake early warning systems. Below are some of the key advances. 1. Rapid data processing. Earthquake early warning systems rely on fast and accurate processing of seismic data so as to detect and locate earthquakes and hence to estimate their magnitude. Big data technologies such as cloud computing and machine learning algorithms process large volumes of seismic data in real time, thus enabling faster and more accurate detection of earthquakes. So this actually helps in identifying the impending um, surface damaging waves even before their arrival at the major infrastructural features. Improved sensor networks. Earthquake early warning systems require a dense network of seismic sensors so as to detect and locate earthquakes. Advances in sensor technology, such as development of low-cost miniaturized sensors, have made it possible to deploy larger and more denser sensor networks. Big data technologies can be used to process and analyze the data from these sensors, improving the accuracy of earthquake detection as well as location. Next is integration with other data sources. In addition to the seismic data, earthquake early warning systems can also use data from other sources like GPS and satellite imagery so as to improve the accuracy of earthquake detection and location. Big data technologies can also be used to integrate and analyze data from multiple sources, providing a more comprehensive picture of the earthquake activity. Mobile applications. Advances in mobile technology have enabled the development of mobile apps that can provide real-time earthquake alerts and other information to users. Big data technologies can be used to process and analyze data from these applications, improving the accuracy and timeliness of earthquake alerts. The National Center for Seismology of Government of India do have similar earthquake detection mobile applications where citizens also can take part. Overall, the use of big data technologies has led to significant advances in earthquake early warning systems, thus improving our ability to detect and respond to earthquakes before they cause damage or loss of life. Next is how low-cost community-developed sensor networks improved the advancement of big data seismology. Here we are dealing with one single example called Raspberry Shake and Raspberry Boom Monitor Earth, which sensors which monitor Earth and atmospheric activities from two different perspectives, making them the perfect complement for a more complete picture. They conveniently snap right into a Raspberry Pi, the most popular single-board personal computer in the tech world. Once we plug in, we are ready to start monitoring and connect with hundreds of other similar largest citizen-powered Earth monitoring network and discover fascinating events from and around the globe in real time. If we check the station map, this is the global distribution of Raspberry Shake sensors all over the world. It's almost equal or better than worldwide seismograph network, and in real time it can detect earthquakes of very smaller size as well as very large plate boundary earthquakes. With this, I am ending my talk, and it actually shows how community developed systems can be a leading point in the big data seismology domain. Thank you.
Thank you very much, sir. That was indeed a bulk of information for us today. Uh, so I would like to extend a warm thank you to you, sir, for agreeing to do this along with us. It's been a pleasure. Right now, I have a question. Please educate the viewers regarding the courses that they have to take post plus two if they want to pursue seismology as a career choice.
To start with, it will be better to join for postgraduate courses in geophysics at IITs like IIT Bombay, IIT Dhanbad, IIT Roorkee, and IIT Kharagpur. There are also universities like Cochin University and Kurukshetra University which offer postgraduate courses in geophysics. There are MTech courses also which deal with computational seismology at Tezpur University. So these courses could be a good starting point to have a better understanding about Earth processes and Earth structure. Thank you.
In a country like India, we see that seismology as a course, so if we study, so where would we get employed? That's also one of the most important thing a student needs to know.
Yeah.
So once we finish a degree in earth sciences, because seismology comes under earth sciences, so where do we start working?
In the initial talks, I talked about passive and active seismology. So passive seismology is about the earthquake source processes, but active seismology is more intended towards exploring Earth for exploring natural resources. So both these domains offer employment opportunities as well as R&D opportunities for any student who is planning to do a course on geophysics. Exploration seismology actually gives opportunities in oil industry as well as mining and similar industries. Whereas passive seismology, if you are making it as your domain, most probably you will end up in R&D institutions like ours. Thank you.
Okay. So thank you, Anilsa. Thank you one and all for joining us today. We are coming to end of our session. Before we go, I would like to inform you all that CSIR-4PI is organizing another YouTube webinar over the topic, the science of cloud seeding in Kannada language. So hit the bell button below to keep yourself updated of our content. Lastly, like, share and subscribe to our YouTube channel to see more of these educational videos. Thank you, namaste, and see you all next time with the science of cloud seeding. Thank you. Have a good day.